Okay, hey everyone. I think Eldritch might die if he goes much longer without getting a first. Congratulations, though, Spetry. Oh my god. Just cleaning house. Hey, Stooky. Alright. I think we're good. We're good to go. I think to start off today, I was gonna do some more analysis studying from Zach's class, and we ended on this one that's on screen. Sentient being, presumably. Yeah, presumably. We don't want to make too many assumptions here. Do I say if I'll stream today in Discord? No. I have the announcement. Like as when I hit the go live button, an announcement pops up in Discord automatically, but I don't really announce it in advance. To be honest, I just kind of hit the start streaming button. I normally haven't decided until like 5 minutes before I start streaming, to be honest. Are you unemployed? Oh gosh. We should see where that line of questioning is going. Oh, because Spectre's always around to like get first. No, I mean I do always go live like around this time of day, but or if I do go live, it's usually around this time. But I don't know. Tomorrow I might go live a bit earlier if I wake up early enough. um. So we answered A through D. Hey Rex, how's it going? Um, critical. I don't know. Like 2 hours or something. uh, and like I'm sorry, but I just I don't know how to do this form to 1040 stuff. If I stream tomorrow, it's gonna be games. Hey Scorpra. Um, we got the blue lights now. But just okay, so just to briefly answer, oops, A through D again. So we can just have them up there. This inequality is true because we can say that the left side is equal to f of x minus f of c, and we can do some plus minus business. We want an f sub n involved, so let's do a plus minus of f sub n. We also want an fnc. That made me think of that's the acronym. FNC is the acronym for Fnatic and esports team. Freaking hell. That's just a flashback right there to watching League. And the point of this is that you can then do the triangle inequality if you pair them up appropriately. It'd be two applications of triangle inequality, but you would want to take pair pair up that f of x with, I guess it needs an fn that has the opposite sign. So with that minus fn, this f of c wants a positive f sub n of c, so that fits the bill. And then f sub n of x needs that negative f sub n of c. Nice. Neon light, dawn sun, cyberpunk edition, yeah. Ooh, let me check. I think the brightness is where it should be. I'm working on controlling the brightness automatically. It's much more annoying to do than just the color though, because like I want to make the brightness turn down around sunset. Like calculating when sunset is a real pain. And it makes it, and what's even worse is that the lights don't even like pay attention to the brightness that I set them at. I try to set them at like 25%. Or I even try to set them at 10% just for like a test. And then when I go and check it, they'll be at 29. It's like, why, dude? For some reason, I can't make it lower than 29. So I don't know. That's something I'm like working on troubleshooting. And I'm not. If you want to calculate when sunset is, given your latitude and longitude, it's a lot of like calculations. I made a mistake somewhere when I entered it into my freaking programming thing. It's kind of cool to like see though. Hey, 2 Sigma boys. Your question is, if x equals 7, what is 2x plus 3? And for a question like that, I would say that we can do what's called a substitution. Yeah, it is an interesting name. It's actually like the Greek letter sigma too. So the person has it over in the YouTube chat. But if x equals 7, we can take that information and know what this expression is, because that x right there should also be a 7. So let's just go ahead and plug that in. We might also use the word substitute. We have to use, parentheses just to kind of emphasize that that x has become a 7 now. And it's helpful if you ever plug in something that's a little bit more complicated to have those parentheses. And so from here, there's just a normal math problem that we can evaluate. So start with the multiplication. 2 times 7, that's 14. That plus 3 stays where it is. Now we can do 14 plus 3 is 17. So I hope that helps. Let me know if you have a question about that, though. I heard you humans are what you eat. If it's right, I'm 7 bags of chocolate and caramel biscuit, 13 grams plastic bag, 13 bagels, and 12 cans of Dr. Pepper. The plastic bag part is a little bit concerning. And soon you'll be Spectre. Oh my gosh. Yeah, Spectre, if you start having dreams about like Krakens eating you or something, that might be cause for concern. Like you're gonna want to start to like watch your back. So the answer to be f sub n of x minus f of x. We can make that number arbitrarily small because the sequence of functions f sub n of x is uniformly converging to f of x. I'm going to delete that because I haven't seen a question from 2 Sigma about that. And C follows the same argument. Because C is in the interval where it uniformly converges, so it uniformly converges everywhere in that interval. What a crappy like handwriting. That's slightly better. And then D was the trickier one. Oh, right. That's because D is this is basically just a statement, or this is possible to make that difference arbitrarily small because each individual f sub n is continuous. So given an x, you can always name a c that gives you a function value that's close enough. I'm trying to think of somebody come back, but my brain won't do it. I've been there, Spectry. Ugh. One that I still think about, because my extended like family, everyone like our sense of humor is we give each other shit, and like one that I still think about was like years ago. I used to have pretty like long hair. It looked terrible, but one of my uncles was like making fun of me, saying I should get a haircut, and I could not think of a comeback at the time for the life of me. And then I realized later, it's like he's freaking bald. It's right there in front of me. I just need to call him a baldy. That's my biggest regret in life. It's missing out on that comeback. No, it's not my biggest regret. Actually, I don't even know what my biggest regret would be, but or if I even would have one. You could have the attitude that like all your mistakes make you who you are. Top three. Yeah. Um. Okay, so I want to read this question particularly because of E. We didn't really get a chance to discuss E, and I haven't really figured that part out. So Ranger, do you have some kind of bound on X, like X minus C is less than delta? Uh, I guess not necessarily. Like we're given that the individual f sub n's are continuous, and it's not explicitly named, but we do know that X belongs to this interval I, and we can, and it C belongs to the same interval too. And I think it's implied that C is our choice, so we can choose whatever C kind of suits our needs. That's my recollection of how the discussion was going when we were doing this with Zach last night. Or 2 nights ago? Yeah, 2 nights ago. Um, why is plane-wise convergence not enough to prove this theorem? That's the piece where I'm not clear. Also, I did adjust my mic settings last night, so I hope It was more about the volume of my mic. So I hope I'm not blaring in anyone's ears right now. Or I guess maybe the more important question is whether it's still balanced enough with the background music. Next, you consider f sub n of x equals x to the n on the interval 0, 1. Oh, this was an example that we was brought up in the class too, right? Because the thing with that sequence of functions, do I have enough room to keep the question on the screen? The thing with that sequence of functions is, oh, there's a new G-force driver. Well, miss me with that right now. You would start with a line, and then you would get a parabola, and then a cubic, and it's going to basically like flatten out to 0 and then suddenly jump up to 1 right at 1. And so that's a pointwise convergence, but not uniform over the entire interval. It's uniform over part of the interval, but not the entire interval. And so oh yeah, okay. I guess that's just the counterexample that we need. If we were to assume that, if we were to take the same statement, modify the word uniformly to pointwise, we could get a counterexample to that statement with this example that you've supplied, Maxie. Thank you. Now thinking about it, your uncle is a really brave soul. Roasting a hare having being is a pretty risky being bald. Ugh. It's just what my family does. If there's something that can be made fun of, they'll do it. Consequences be damned. So if pointwise was enough, I guess this maybe was the explanation that Zach gave, but I didn't quite connect the dots during the conversation because I think we either looked at the same exact example or a similar one, like maybe with an exponential. But I didn't realize that that was the answer to E. Was enough, then f sub n of x equals x to the n on 0, 1 would imply that f of x equals 0 for x on 0 to 1 and 1 for x equals 1 is continuous on 0, 1, which it's certainly not. What does the contrapositive of this theorem suggest? I remember writing that out, but I didn't quite glean anything significant from the contrapositive. Let's write it out again and think about it. If f of x is not continuous, then either there is no sequence of functions f sub n of x that converges uniformly to f of x, or there is at least one f sub n of x that is not continuous. So, oops. That's just kind of... That is wrong. I'm not surprised. Or like or like this is just if I blindly applied what the contrapositive is. Yeah, and so I wanted to refine the statement because I imagine there's something, there's some justification with the situation where we could modify it. Definitely like this part, I feel like. Like that part feels like it's potentially unnecessary. Like I feel like it should always be the first case. Like there is no sequence of functions that converges uniformly to f of x. But we'd have to look for some kind of contradiction in the second half. I imagine really for any function you find a sequence that converges uniformly to it, just pick f sub n of x equals... Oh, I guess that's okay. Yeah. To claim my reward of the month for my reward of 4 month of dedication and consistency. Yeah, 30 streak. Fair enough. Um, for another 100 streak. Yeah. Did I say that 30 is 28% of 100 at some point? I wouldn't be surprised. If f of x is not continuous, then for any sequence f sub n of x, Hi, I'm new. Yeah, Central. Welcome in. I definitely have never seen you before or played a bunch of DayZ with you. Still sad about my streak robbery. Oh yeah. Another victim of Twitch's shoddy like streak tracking. He knew I'm Spectry. If f of x is not continuous, then for any sequence... So maybe I had it backwards. I mean, maybe this is the contradictory part because of the counter argument, or basically the argument that Amaxi has said. For any sequence f sub n of x, I feel like the thing that we have to fill in for that reason is that converges uniformly to f of x. there must be at least one this, and I imagine there's almost always going to be more than one, but maybe there's some weird example. Like I'm just going to say like the minimum here. Nowhere near general enough. Well, it's got to converge in some way to f of x. Why can't otherwise f sub n could be something random, right? My guess is that every f sub n would have to be discontinuous. I don't really have a justification though. A and B, or if A and B, then C. The negation is of the form not C. If not C, then not A and B. Yeah, and so that's what I... Well, that's this. In my mind, that's what this is, using De Morgan's law. Instead of not parentheses and, you do not or not. But this is just like not changing the phrasing or anything. Like I think this is the contrapositive if you don't consider the situation at hand, but you take the negation of A for all and write A for all. Well, if you have a wait, okay. This is a I was interpreting this as like for all n, f sub n is continuous. That piece of the statement. Sorry, when I say that piece of the statement, I mean this piece of the statement. And so if you want to negate that, if you negate a for an all, it's a there does not exist. Oops, backwardsy. Or there, no, maybe there exists. Maybe there's different forms that you could negate it with. You could say there does not exist, or there exists an n such that f sub n is not continuous. But maybe that's where maybe I should have been going for like that negation. There does not exist an n such that f sub n of x is continuous. What I think is correct is if f of x is not continuous and f sub n of x is a sequence of functions on the right domain, either f sub n does not converge uniformly to f, or almost all f sub n are discontinuous. Should have written either. No, it's good. My logic is pretty basic, so f sub n is a sequence of functions on the right domain. Either f sub n does not converge uniformly, or almost all f sub n are discontinuous. Yeah, I guess you're imagining that's possible to have like the first couple be continuous in some way. but eventually they'll become discontinuous as they get closer. Um, well, I keep thinking about Fourier's series and how it looks as a Fourier series converges to a step function, but I feel like that's like ahead of where the class is, and I also don't know if that's the best thing to draw because I don't know if that's uniform or pointwise. The least most uniform you can make it, but I could be wrong. Yeah, I do like your. That phrasing feels better to me than the phrasing I put here, for sure. At f sub n of x. So sequence functions. I guess not continuous on I. Sequence of functions. Also on I. Then either f sub n does not converge. Hey Phobos, how's it going? Just doing the. I'm trying to write up an answer to number 2 from Tuesday. Yeah, because I still didn't feel quite clear on the later parts of the problem. So yeah, 7 does not converge uniformly, and so Maxi's suggested a good way to do the contrapositive. I think is this third thing that I'm typing out right now. Does not converge uniformly to F, or almost all feels like it requires more justification than we have at hand. But I mean, I feel like we could justify that. I don't know. Or I agree that it should be almost all, if not all. I'm just gonna write that as Maxi wrote it though. Or I guess maybe the word almost is potentially vague. But other than like wanting to think about that more, I think I do like this third one. Almost all in the sense of all except a finite sequence or any finite subset natural as a maximum element. Yeah, okay. I do like that. Uh okay. I like this. I don't like that I didn't fix my line break. All right, I think I'm satisfied with number 2. Maybe we'll bring in number 3. Absolutely, Phobos. Yeah. Let me I don't know if you have a better way, but like this PDF has a bunch of random stuff in it. If I would just want page 7, the only thing I've been able to find is printing to PDF. That doesn't come out the greatest, but it doesn't seem to let you. Running print operation failed with percents? What? Zoom out and do a screenshot? Okay, that'll be even easier. Yeah, it seems like it's legible enough in the screenshot. Failed with percent? It's a great error code. Um, two. Um, oh my god. Discord. Okay. Why is my Discord being so slow? Maybe. Oh, because I had it split across 2 monitors? That's so weird. Okay. But. Okay, it's posted there, Phobos. You know, I guess I've also failed with percents before, so maybe I shouldn't be judging Journal++. So this is... Isn't this a linear function, and we're just going to have different slopes happening here? Presumably approaching 1 in the long run? Before we try to actually answer the question, let's draw out a couple examples for M. um, f sub 1 is a half x. Maybe we draw them all in the same plot. F sub 2 is 2/3. F sub 3, 3/4. And just one more. Four fifths x. Now let's draw these out. They're asking about many different intervals, so we'll dip a bit into the negatives also. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So 1/2 x, rise 1, run 2. I'm just going to draw it for all r. F sub 2, rise 2, run 3. I expect these to get steeper and steeper, but kind of have a stopping point at slope 1. That's my intuition here. 1, 2, 3, 1, 2, 3, 4. These are like the straightest lines I've drawn in my life. And I won't hear anything different. 2, 3, 4, 1, 2, 3, 4, 5. I'm just gonna fudge it. I shouldn't have put an actual scale on this thing. Okay. You can converge uniformly on each of the following intervals. Why or why not? I feel like we need to use prompt 2 here, right? Each individual f sub n is continuous. I guess, well, they're asked. Oh, never mind. I mean, prompt 2 feels like it's backwards, though. We already know f is continuous. I don't think the contrapositive helps. Yeah. I can't imagine there's going to be well, maybe an open interval makes a difference, but I feel like A through D are likely to have the same answer. Maybe C will be an odd one out. I don't imagine the actual choice of endpoints though is going to matter. It can disqualify uniform convergence. Yeah. Same here, Phobos. It definitely feels linked to continuity, but I don't think it has to be, which is where the struggle is for me. So uniformly convergent. Maybe let's bring in the definition again. That's a nice way of thinking about it, Maxi. I like that. Hey, Emma Deblam? I'm saying that right? Master student here. I did this years ago, and this looks mank. I'm not familiar with the word mank either, but it does sound kind of funny. Grim? Oh, okay. To just draw stuff. I definitely appreciate a good visual. Yeah, this type of stuff isn't my strong suit, but it's kind of interesting to learn. I just have a bachelor's um, in applied math even, so I avoided a lot of the proofy classes. Um, because I see your first time chat, I do like to let people who are new around here know that I'm not the only math streamer who exists. There's a whole little like niche of us in case you're interested in like the idea of a math stream in general. Creative and unique, something that got cut up. Thank you for the follow. And this particular set of problems that I'm working on right now comes from an actual real analysis class that's being taught live on Twitch by e to the 2i pi, who's listed in there. So they'll be meeting. The next meeting is in, if I can do math, like 3 hours and 40 minutes. And so I'm just doing some of the prompts from the last class. It's real analysis, but it's focusing specifically on infinite series. It's like a part two of a previous one that he did. I suppose I haven't seen those. Yeah, it's probably a little too. I guess at that point it's early in the morning for you. Yeah, unfortunately. Talking another stream that I would consider doing master streams on Twitch if I could get an audience. Oh, I mean, an art stream. Yeah, I mean, if you do anything that's math focused, like I would definitely check you out. And if the time works out, like raid or shout you out or something. But yeah, like getting the audience is always the hard part. um, there is a linear algebra class that's happening. That's probably a better time for you, Maxi, over on Penn Center's channel. I think those start. Oh gosh, 6 hours ago or something. It's probably even like afternoon for you. I bet it's like pretty early in the morning for me. So I don't really wake up early enough to see it. Um, Thinking that niche of advanced maths explained less technically, but my advanced math themes are Hilbert space and discrete probability. Those are very hard. Yeah. I know nothing about Hilbert spaces, and I assume the discrete probability you're doing is a lot more advanced than the discrete probability that I'm thinking of. I mean, I can say it definitely in the math. If in the math category, there's a good amount of people who keep an eye on it and will definitely like take a look at your stream. And I think there will be people who are interested in talking about those topics too. Yeah, I used to do it a lot more. I need to go and do it more often. I've been bad about it, but especially when I first started streaming on Twitch, I looked at it quite a bit. Random graphs, connectedness, clustering, percolation, and that sort of vibe. Oh, wow. Yeah, no. When I hear discrete probability, I think of things like what's the probability you draw a red ball from the box or whatever? Like those types of problems that involve discrete things and ask about a probability. But yeah, that's definitely a very farther advanced thing. Combinatorics. Yeah, you probably learn that more often in combinatorics class, but um Do a related project by vibe of the class. Oh, cool. Okay, I really just want to say yes to. Honestly, I want to say yes just to A through E, but there's got to be a trick here. Like, it's not. There's no way it's going to be yes to all of them without. Like, it's not going to be yes to all of them that easily. If a sequence of functions f sub n of x converges uniformly in an interval I, if random epsilon greater than 0, not all are yes. Okay. There exists an n belongs to n, or if n is greater than epsilon. Ugh. Okay, let's consider. Let's take part A first. Oh, Papadoria. There isn't a line right now. I'd like to finish my train of thought on this one, like, studying problem that I'm doing right now. Uh, but I still have your question copied up further in this document, so I can bring it right back up. Do you have a theorem that if fk converges uniformly to f? This is the theorem that we just did in the previous one. Each fk continuous and bounded, then f is bounded. 2 is related, but that feels backwards because I mean, this might be a slightly different theorem because at least when I looked at 2, it didn't seem like I could use that to my advantage, but I'll keep it up there for another little bit so you can read it. In Papadoria, so that three blue one brown video is all about that one problem, and the answer to it is kind of crazy. I could try and provide the broad strokes of what I remember though. That theorem is different. Okay, then I don't think we have the theorem that you're talking about. A different direction. Okay. I guess this is M, not N. My proposed limit is just x is less than epsilon. Make sure to check it out. Still doing problems during the stream as well. It's quite interesting to watch. Yeah. uh. Oh, I think I see the trick with this now. Uh. Yeah, I definitely wouldn't be able to I will not forget problem out myself in a million years, but it was an interesting watch that video, and I'll put the link back in chat here today too. Once we switch over to that problem. So I think the trick here is that we can't really deal. I mean, I guess we could. Does a triangle inequality actually help? Not necessarily, but maybe. the issue that I'm now realizing we have is that I don't know how to deal with that with this absolute value, because when x is positive, this quantity is negative, but when x is negative, this quantity is now positive. Oh, that is a good call zone. Yeah, I guess we need an m in the numerator there too, but yeah, I can definitely. I assume we'll still run into the same issue, but maybe not. Maybe I'm just not good at math. There's a possibility too. But I assume we're gonna run some issue with positives and negatives. That seems like uh wait. We want to solve this for m. No m in the numerator? Oh, I see what happens. Right. Because m over m plus 1. I should know better than to doubt you, Zone Ranger. I don't know why I doubted you there. It's because it's actually this. And so you have to get a common denominator there. In the absolute value takes care of the negative sign you get. Okay, cool. I forgot to work that out in my head. Get rid of that m. Ugh. In that case, we'll put the absolute value of x on top. Okay, and so with these, we want to solve it for m. One thing at a time. And so the key thing to figure out is whether our choice of m actually does depend on our choice of x, or if we can somehow cut that x piece out. Because I think we definitely say this thing converges in some way, but we're deciding between uniform and pointwise. In uniform, our choice of m cannot, it can only depend on epsilon, not x. Can you say for the function g of x equals x on a compact interval? I have no clue. uh well, why would we ever choose a negative x though? No, I think we okay, maybe it's not the signs that are the issue. We would always just take the positive. Yeah, here's the original problem again. Yeah, they are just lines. So if x is bounded, then x over m plus 1 approaches 0 as m goes to infinity. Interesting. And it sounds like color couldn't maybe going in the same direction. Okay, yeah, so at least when I think about these problems, I try to think about like the worst case scenario and bounding that. So, or if the goal is to get rid of x from the expression that I just found, or I guess we just found, because I definitely had a lot of help with that. This is f of x, and then a generic f sub n of x could look something like that. M. And so the worst case scenario is always at the endpoints, right? So we could always choose. In this case, the endpoints are symmetric. So we can choose either one. X equals 1 or -1 would work. So I think m greater than epsilon minus 1 is a fine enough choice for part A. F sub n, if f sub n approaches f uniformly, if and only if supremum of x absolute value, or supremum for x, the absolute value f sub n of x, as fx approaches 0 as m goes to infinity. Huh. I mean, I wouldn't want to use that because it's not what we're provided by the class. It is good to be aware that that exists, though. I want to not stray too far from the tools that we're supposed to be using, though. Uh, I have a feeling for parts B through D, then, we're going to choose whatever endpoint has the greatest absolute value. So for part B, we repeat the same argument, but with x equals 5. Part C, we repeat the same argument with x equals 7. And part D with 22. Does the open... I don't think the open interval... Oh, the open interval makes a difference. We need part C. Part C is a potential issue. We can't say x equals 7 because x isn't a part of the interval. I think part C is that it doesn't converge uniformly then. Can I still pick the epsilon? Oh, I guess, yeah, that's true. I could just say x is less than 7 for part C. Yeah, okay, fair. I'm gonna say, like, but switch. Not necessarily equal, but 7. Then you got a limit question involving trig functions. Uh, that's gonna take a bit of thought. Well, maybe L'Hopital's is the way there. Maybe that one I won't be too bad. Oh, maybe it's bad. I can't tell yet. uh, Papadori did ask a question first though, so I might need to get to yours after. Shoot, and I'm taking longer this question than I intended to. For part E, over all of R, Let's recap. Yes, 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 yes. So in part E, this difference here is going to be growing without bound, right? For a given m, but I mean, we're choosing m. It's no, because that would make all 5 parts yes, QED. True. I mean, yeah, I do have that in the back of my mind. Like, I I'm thinking this thing should be no, because there's no way they're all gonna be yes. And I've absolutely used logic like that on tests too. Like, you can get a fair amount of questions right just by using like logic like that, or I guess like psychology. I don't know, but I do think it's gonna be no. I'm just trying to like figure out why, and it's got to be something with we don't really have a clean upper bound for absolute value of x, like we do when we have um finite endpoints. Uh, like we would have to plug in x equals infinity here, but that's not really, you know, a thing. Yeah, I remember you saying that, Zone. Yeah. That would be a funny troll to actually like have multiple choice exam and make them all C or something, and see like if people change the answers just because they can't all be C. And now pick C, exactly. I've heard that C's get degrees, so clearly you should pick C. Gotta go. All right, Zone. Thank you for the help there. In case you don't get multiple choice exams. To be fair, I don't remember the last time. I probably led multiple choice exams for like a gen ed class or something. I don't think any of my math professors use multiple choice, except for like the automated. Oh, okay, the automated homework things definitely have multiple choice questions. That's like crappy textbook provided websites. So I think I said intuitively why we can't justify uniform convergence for R. Annoyingly. We don't have a clear upper bound that we can plug in here. Or like supremo. I think there's maybe like a better way that I could phrase that. But I think that's the idea behind why I use no. And I do want to talk to Papadori about their question. I had a question my second, or I had a question my second course Markov chains unit, where I thought the question was about the movements of cars through a car park. Those are parking spaces between occupancy statuses. It was a gargantuan troll. Oh my god. That sounds so terrible to think about. Yatharth. A thin hoop of diameter d is thrown onto an infinitely large chessboard with squares of side L. What is the chance of the hoop enclosing 2 colors? I have no idea how to do that, Yatharth. I'm sorry. Okay. But Papadori has been waiting, so I want to talk about their question first. And for anyone who's new around here, I dual stream to Twitch and YouTube, so if you hear me talk to someone who's not, you're not seeing in the chat, that's why. The chat up there is only the Twitch chat, because Twitch has a stupid policy where I can't show the YouTube chat. Cost me 20 minutes to understand it. Only figured it out because I was asked for the Q matrix of one party in space. Oh, dang. At least there's that question then. Very close to 1K subs. I saw that. I'm at like 952 or something. The 900's been slow for me. I think because I was streaming less for a good while. So Papadori with this question, I don't know how much you want me to say. So actually, oh, I did promise I'll put the 3 blue 1 brown video in chat. Let me go and find that again. It should be my YouTube history. Here it is. Stop! I kept clicking on the on the wrong thing. There it is in the Twitch chat. There it is in the YouTube chat. And so I don't know how much you want me to say, Papadoria. Thank you for the follow, Emma Dublam. So then Papadoria asked their question first, and I don't have a clear way of thinking to do yours. I'll write it down here, but like if Lopitals, I don't know that Lopitals immediately gets us the answer, and that's why I'm not going to it first. If I just knew how to solve it instantly, then I would just kind of try to do it quick. But I don't. Oops. I don't see what to do after applying Lopitals is the issue. But this is the question that's on deck next. Say as much as you can? Okay. So it uses generating functions. He starts off by counting the total number of subsets. And the way you think about that is for each member of A, you have a binary choice. Do you include it or not? So for the 1, you have 2 choices. For 2, you have 2 choices. For 3, you have 2 choices. And since you have 2,000 elements, the cardinality of A is 2 to the power of 2,000. And as it turns out, you can make a generating function that emulates this kind of like repeated binary choice, which is f of x equals 1 plus x times 1 plus x squared times 1 plus x cubed dot 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 1 plus x to the 2,000. And so that's the thing. I never studied generating functions myself. It's a whole rabbit hole that you can go down and study. I think you more or less pull this function out of your ass and think about how it's similar to the problem at hand. That's honestly the best. He more or less said that same thing in the video. So it's just some function that is somehow related to the problem in some way is my understanding. And the point is that if you were to go through and multiply this out, the act of doing that like FOIL emulates these binary choices. So if you wanted to get like this one can get distributed to that one or to the x squared, and you know, of course, you're going to end up doing it to both to get the entire thing. And the point of this is that if you were to multiply all this out, you don't have to actually multiply it all out, but you would get 1 plus, I forget how he was doing it. Like something times x plus something else times x squared plus something else times x cubed, yada yada yada. And the coefficients of each of these are the number of sets, the number of subsets that I think is divisible by that power. Now my memory's starting to fade a little bit. But that's the connection between these two. Or it's at least like something like that, where the actual coefficients are counting the exact thing that we want, that are divisible by 5. And so the kind of point of this is to figure out what is the C5 coefficient, because that's the one that goes with x to the 5th. And so so yeah, and so now and getting C5, that's where it gets even crazier. So it seemed to me in the video that the hardest first step was realizing that this generating function is actually helpful. Because it's really just random and out of the blue if you haven't studied generating functions, and I sure haven't. And trying to figure out what C5 is, fuck organic chemistry, there I said it. I think you have a lot of people who will agree with you. You can figure out what C5 is. With great difficulty. This is where my memory is really going to start to break down, so I'm just kind of giving you the broad strokes here, but there's some values of f that are pretty easy to figure out. Like f of 0 is just 1, because it's 1 times 1 times 1 times 1. F of 1 is 1 plus 1 is 2 times 2 times 2 times 2, 2,000 times. So 2 to the 2,000. But f of negative 1, you get 0. And so you could figure out, you could use this to figure out what C1 is as an example. I think is what they were doing, because it's something like if you take the average of f1 plus f negative 1, oh man, no, I was getting really into the weeds here. Crap. No, I'm losing the thread here. You're somehow able to use this to make a statement about there being an equal amount of even and odd constants, but that's not really directly helpful to the actual problem at hand. But you can like learn some things in general about these C's. There's an equal number of even and odds. There's a symmetry where I think like C1 equals C 1999 or something like that. No, we only need to find C5. C5 is going to be the answer. These C's count, I think, how many subsets are divisible by each of those numbers, I think. I have no idea what he says, but he's cute while he says it, chat. Thank you, Central. Oh, I mean, okay, that's actually 2 to the 1,000. I forget how you use that helpfully. C5 is right there, I see it. Yeah. And so you can use a similar, like, instead of plugging in 1 and negative 1, you take a complex number zeta. Oh, Midwest Batman, thank you so much for the raid. I gotta confess, I haven't heard of your stream. Oh, Brian, did you suggest me? Well, thank you so much. I'd love to hear what's your stream about. What were you up to? I hope it went well, and welcome in. I'm Don. I do math help streams. I also do game streams, all that good stuff. We're just working on this question that's listed at the top here. Or I'm trying to recite my recollection of a video answering this question is more like it. And this is a terrible Zeta, by the way. That's an even worse Zeta. I don't know how to draw Zeta. Um, instead of plugging in like 1 and -1, you actually want to plug in I don't know. A complex number zeta that is, well, you want to plug in all of them. You want to plug in, let me just write it like this. You want to plug in the fifth roots of unity in order to get C5. And the reason that you do that has something to do with how they rotate around back to 1 every 5 powers. And there's even more tricks after that to evaluate it with those complex numbers without having to do a bunch of math and expanding things out. Some dimensional politics and putting them in some math. Oh, fair enough. Sounds like a nice time. So yeah, Popular, I think that's as much as I can recite from memory of the video. It was a really cool video. The answer is 1/5 F zeta 0 plus it's 1/5 of each of the roots of unity added up. I can't draw zeta for the life of me. This is, I think it's physically impossible to draw zeta. That's a conclusion that I'm coming to. I think he was writing them like that. But that'll be the final answer. That's equal to C5. I believe. I may have some details like slightly wrong there, but that's kind of like broad strokes the big idea of it. And so if you've never heard of generating functions and your professor gave you that question, I really don't know how you do it. That seems mean. No worries. I don't know of an alternative. I didn't really look into it. Maybe there's an alternative solution. I think it is an Olympiad problem, yeah. Yeah, I definitely don't know either, Papadoria. Uh, it's apparently in a pretty, or like it was included in a book, and Blue and Brown made the video about it, and I think it's made the rounds in some places more than likely. Okay, so Ved, if you're still here, thank you for your patience. I'll type your name in chat in case you're maybe you may do a stream or something just to go and do something else. So with this one, if you try to evaluate it directly, you do get 0/0. So L'Hopital's applies here. I can't promise that L'Hopital's helps, but we should take a closer look at what L'Hopital's gives us here. Oh, wait. Oh, no! I made Ved wait for nothing. Oh, no! You could just evaluate it directly from here, and I didn't even think about it. I forgot cosine of 0 is 1. Yeah, Papadoria. Oh, man, I feel so bad. When I was doing this in my head, I thought we were getting 0 over 2. And that it... Well, even then, that's okay. Yeah, no, I did this completely wrong in my head. Damn it. Hey, 750. Ah... Moment as greatness approaches infinity. Thank you, 750. I sure don't feel like it right now. I was so transfixed on using Wapitals in the first step. I thought we would need to do multiple applications of it. But as soon as I saw we would get 0 over 2, I was like, oh, well, I can't use Lopital, so clearly that's wrong. But even if I was right that you get 0 over 2, that still will just be the answer right there. Oh my god. You love your physics teacher? I'm his favorite? Oh, nice. So it's good to have a good teacher. Man, crap. Yeah, I would have answered Ved's question before diving into Papadoria's if I realized it. Let me... Okay, let me type in the YouTube chat again. Ved, if you do come back... Okay. When he wants to grade by the lesson, he goes by 4, go out 4? Okay. So showed someone who stopped math at 16, getting the lowest pass grade at GCSE. My measure theory exam, I was explaining rings the same percent at 1 a.m. I don't think I judged that too well. Oh no. Normally people will just like shut you out if you try to do stuff like that. One second, my mom just texted me. Let me reply to her. Um, okay. To be fair, but they did go, oh my gosh, this is a lot looking at I bet. Yeah, for measure theory. Should examine my first date with her? Oh no. It was a date? If she can't handle you at your limb imp, she can't handle you at your limb soup. Oh my god, that's hilarious, Phobos. I'm pinning that. I love that. Didn't put her off me somehow? Wow, that's a keeper. Oh my god. My girlfriend is having trouble sleeping. I start talking about my research and she falls asleep in no time. Perfect color. I guess maybe we'll go back on the analysis train. I'll wait to see if someone else pops in with a question. Oh, this one's in two pieces. Unfortunately, I find her stuff interesting, so she tried to talk art to me to get me to fall asleep. I'd actually stay awake. Oh, we aren't together yet. It's a pre-official stage. Shouldn't be saying yet. Oh, yeah. That does look like a funky sequence. One second. Making coffee arrangements with my mom. I got priorities here. Um, how early do I want to wake up that day? No. Okay, that's fine. Let me put a reminder for myself because I know I'm gonna forget. Almost done. Okay. I feel like I've dealt with some of my exam for this course. I had to do some annoying calculations. Yeah, normally the way to go in the problem set, the more they become kind of bonus challenge problems. Inverl, uh, I want my free tuition back. It's an unforgivable typo. Differentiating, interesting. I need to see how this sequence of functions even looks, to be honest. I think this is a Desmos error, actually. It's gonna be some kind of messed up bell curve, right? I don't quite know what the X in front is gonna be doing to the bell curve. Is it? I imagine it's honestly like gonna be tilting it in some way. That's gonna be interesting as the because I think this number up in the exponent is gonna make it like narrower and taller. Huh. Let's hop over to Desmos. I can say for sure it's fucked up. Okay. Oh, no, the X, really? Oh, right, the exponential dominates. Oh, I forgot the X. That's why. Okay, that makes way more sense. Yeah, I am. Thank you. Differentiating is difficult after two things are integrated. Yeah. I was wondering why I didn't look any different from a normal bell curve. Oh, okay. So this is okay. I'm glad we went to Desmos here. So it. Oh, yeah. This is a fucked up function. Um, I think it's just uniform convergence at zero. It's got to be right out. Uh, yeah, I know. If you hit play. Okay, so the thing that's happening with this one is if we're looking at the portion where x is greater than or equal to zero, I would say this function is converging towards 1 for x equals 0 and 0 for x greater than 0. But if we restricted it the other way, we're getting a negative 1. And that's the weird bit here. Yeah, so that's why I'm thinking that uniform convergence for anything involving 0, it's just right out. Brain is screaming at me. Yeah. So to respond to part A, I think proving uniform convergence on, say, one, do we care about a finite upper bound? Like, okay, like 1, 2 is a very safe choice. I wonder if we can say something a bit stronger, though, and say 1 infinity. Yeah, we can. Because we can, the worst case scenario for the error um, is always going to happen somewhere early on in the interval, right? I assume we want to, we can, is the maximum, I wonder, ooh. I'm interested to investigate where this maximum is. Maybe that's where you're doing the derivative, Amma? Integral test? I don't know how an integral helps here. It would be easy to integrate. Um, I'm interested to figure out what the maximum there is, though. Yeah, because maybe one isn't such a good choice, right? No worries, brain. I like I mentioned the integral test for like a regular series is what you're. Oh, like a power series? No, yeah, I think it's like a different. This is just a sequence of functions, not like a power series. Um, so we have a product rule here. Is that our derivative? Feels okay to me. And if we set this thing to be equal to 0, n minus 2n squared x squared for a fixed n, e to the minus nx squared equals 0. E to the power is never 0. Hey, Zappin. Yeah. So we can worry just about this piece of the problem. This is looks like a lit problem. Yeah. Do you know e to the 2 pi or Zach? This is from his real analysis class. Okay, yeah. So the next session is going to be in 15 minutes plus 2 hours. And I'm just doing some problems from the last problem set on Tuesday that we don't have time to get to. Yeah. It's at 5:30 Pacific time, but I don't know what time zones people are in. So I try to say like to give time like that instead. Oh, you're an EST. Okay. So it'll be like 8:30 for you, I think. Just look at my tags. Yeah. It's funny, my Twitch recap for some reason said I think the Ed Sheeran stunt double tag. It said it was one of my most successful ones. There's no way it actually was, but I think the recap is just glitchy. It was kind of funny to see that though. Lecture kept saying modulo blah during lectures. Oh no, that sounds confusing. No, if you actually, or if I actually look at the analytics, like math is usually the best one. I think like maybe tutor is the next one or something. Um, but it was funny to see the Twitch recap like say that Wikipedia speedrun. Yeah, from Ed Sheeran Sensible to math. Yeah. um, x squared equals 1 over 2n is what I'm getting. It's annoying it depends on n. Assuming the n dependence would go away. That's okay though. It's okay that it depends on n. That's fine. Um, and so I would actually revise my beginning endpoint. Um, ooh. No, how am I revising it? Differential equations, Lagrangian Hamiltonian systems course, in some canonical transformations. So she say, for example, modulo a change of variables or modulo a sign error. She was diabolical at doing bashy algebra on the board. Oh no. I thought she was literally doing like mod 3, but not being specific about what mod. Like in a lot of like and isn't there like number 3 problems or something where you like just take everything mod 3 or whatever, but like you don't care what mod it is? Oh, color cone. Yeah, true. Because we know the first value for n is 1, and so the most this thing will ever be is 1/2, right? Uh and so I think that works perfectly because as n increases, that hump is going to get like it's going to be less than the 1/2 increasingly so. So I think 1/2 is the most generous x value we can easily choose. I think you could choose another one, but that's the most convenient one, I think. I'm doing any module number theory sense. Okay. Oh, root 2. I'm a monkey. Ooh. The same is still true of this, though, right? Are we saying root 2 over 2? Yeah, I guess. Assuming this that we don't care about this way. Yeah, that's terrible. I think I'd be really confused in that class. Okay, I think root 2 over 2 is, by the same logic is a good choice. Uh, for not uniform convergence, 0 infinity seems like a good enough choice. I don't know how much justification we need for that. I mean, it's not continuous, right? And I think that's enough to justify it's not uniformly convergent. I hope. I loved her lectures and found them very enjoyable, but her problem classes were trash. I had problems on my own anyway, though. Okay. I guess that makes it better then. What does a sequence uniformly converge to in the interval from part A? It feels like a boring question, right? Isn't it just 0? Infinity is a psyop. I don't really know how, but you know, I'm not one to uh say no to an unhinged statement. Hmm. Is it if f is not continuous? That's enough to say that you have no hope of uniform convergence, right? What was our contrapositive? Or they're discontinuous. I know our f sub n are continuous though, so Leibniz-Newton conspiracy, the frenemies thing was misdirection. Infinity isn't even real, man. That's a conspiracy theory I can get behind. Throw this analysis stuff out the window. Yeah. I think I agree with that. Emma DeLam. Ah. Inverl again. The copy pasting. Should we go straight to Desmos again, or should we try and rewrite this first? Maybe let's explore rewriting it. We can do some +1 -1 business. I love these little rewriting things. Yeah, you know, the sequence of functions cometh. He does like to put jokes in his prompts. You should see, like, so this is the second edition of the real analysis class he's done, or like the second like semester. By the end of the first semester, like it was like unhinged. Like he was using all sorts of things for variables. He had like F of like ninja emoji or something, I think. And so we had to use the ninja emoji for our variable. It was funny. He ran through probably every single Greek letter and then didn't like reuse any. Why did my N become a 2? Least serious analysis professor for real? He probably. I imagine him as generally a pretty uptight group of people. All my analysis professors bar one have been really serious. Okay, yeah. I think I'm still going to Desmos this one because these rational functions are going to get kind of tricky with the powers. The thing that I wrote might still be helpful in some way, but I want to leave this to Desmos. Can I ask a question I saw on Reddit today I haven't put any thought into? Sure, Mega. When I got us to draw a funky turkey using his instructions, that's kind of hilarious. I like that. Oh, that's not what I was... Oh, wait, that's n equals 4. N equals 1. Oh, that's still not what I was imagining. Why is there no asymptote? Oh, that's n equals 2. There's the asymptote. Another one made fuck tons of political jokes and comments about extremely current events. That's risky. Oh my gosh. There's definitely some places here in America that first will probably get in trouble for stuff like that. How many subsets of 1, 2, 3, n are there such that the average of the elements is a subset and the subset is a whole number? No, so I don't think it does. I was just wondering where the asymptote went for the other ones, but oh no, there's an infinite number of asymptotes though. Oh my god. Every odd n has an asymptote. So let's think about Megalomorph's question first, but that has a similar feel. It goes to infinity, but it feels like a similar situation as the previous problem, where depending if you have x on one side or the other, you get positive or minus. Plus or minus is the same thing. Um, hey, Famished. Now this one feels pretty similar to the one we were talking about on Tuesday. And I hope you're not expecting me to be able to answer this because I definitely can't, but I can think about it. You just woke up? Oh gosh. Because I don't know what time zone you are, but maybe you woke up at a reasonable time. You have no clue how hard it is. Okay. Oh, you had a nap. Okay. I didn't like you woke up for the day. Oh, it's 6 p.m.? Dang. Uh, Maybe even n is a little bit easier to consider. You have a lot more assurances for an even n. So let's for a little bit, let's live in that world, right? If n is even, we only need to throw out subsets with an odd number of odd numbers, right? And maybe there's some convenient way to calculate that I haven't worked out yet. But I think you can count every other set or subset. Oh, wait. No, I'm thinking about this wrong. I'm thinking about this wrong. Nope, 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 nope. I forgot that the average. For some reason, I was imagining the average in the denominator is always n, but that's not remotely true. Yeah, and the singletons, like you say. Well, that's a good point. Every singleton works. Ever drinking coffee before midnight? Oh my god. Yeah, it sounds like a terrible idea. One coffee twice a week? Oh wow, that's not much coffee, but you know, with that rule, just wait until it's 12:01 and then you're good. Okay, if I wanted to modify the idea that I had, you could consider subsets with an even cardinality. That feels like it's getting maybe too niche to be helpful, though. Still, I was getting my GED, so it kind of helps. Drink it as needed. Don't drink of it. You know, fair enough. Yeah. Set 135 has an average of 3. Oh, maybe you're looking at that like symmetry. Or no, you're responding to Amma. Can we force a symmetry on these subsets though? Like, can we ever have, like, does the median have to be, I guess, would it have to be, like, I guess, like, evenly spaced? Like, if we start with 5 and you increase or decrease by 2 each time, does everything have to look like this? I don't think so, right? And I guess I'm only talking about odd numbers here with a clear median. Or, I mean, even numbers have a clear median too, but not a helpful one. Um, I don't think so. I think you can mix and match. Like, could you... Can I name odd number elements without this symmetry? You have to play with the distances. Well, maybe they do need to have this symmetry. No. Yes? Okay, wait. 1, 3, 5, 7, and then these. Wait, these all add up. 4, 9, 18, 25. So if I made that a 25, I think this would also have a whole number. Because we're getting 50 over 5. Yeah, okay, so that symmetry is not required. There's some symmetries you might be able to use, like if you add 1 to every element, preserve the property of the average being a whole number. Oh yeah, true, true. Oh, that feels like a linear algebra thing. That feels like a vector, like being dependent. A different version of that. Maybe that's the wrong connection to make, though. If you replace every number x with n plus 1 minus x, that preserves the property. Ooh, interesting. I don't know if you can exploit this. Me neither. Yeah, I'm having a hard time coming up with a general statement. The only other thing I think to do is look at some easier examples to start with. This is a simple enough case. Hey, mathematician, yeah, I remember you. Hope you're doing well. Wow, my brain doesn't work. Why? Why? No, I didn't stream on YouTube yesterday. I streamed some games on Twitch yesterday. Is there an induction here? Every time you go one further n out, you always have the same previous subsets, right? You're only adding on new ones, potentially? Well, certainly, but... there was probably an induction somewhere in here. Not that it's easy. No, it's still gonna be really difficult for higher numbers. So you have to worry about subsets like that one. Got a subset with an integer average isn't a singleton yet. It's either contain that average or it doesn't. Removing the average or including the average to give you another subset with the same average. Oh, true. Yeah. You could remove the 2 from this subset and end up with this subset. That could hint at an algorithmic process, right? No, not necessarily. Use this at 1, 5, we get 1, 3, 5. Do it to 1, 3, 5, we get 1, 5. Yeah. Oh, wait. 1, 5. Yeah, okay, okay. Breaks things up into pairs except for the singletons. You can count the number of subsets of size k that have remainder r when divided by q. I don't think I can do that. Maybe someone can. Count the number of subsets of size k that have remainder r when divided by q. I'm not quite sure what you do with that idea. Hmm. Now, I am also noticing that in going from here to here, we increase by 1. Going from here to here, we increase by 2. From here to here, we increase by 3. Could there just be a really easy pattern like that? Like, that would be nice. Oops. It would be lucky. I completely agree. Uh, it's probably no. Probably is gonna break the pattern is adding even versus odd uh integers. Like I'm only adding two here in this stage, unless I'm missing a subset. One, two, three, four. No, one, two, three, four works. Yeah, okay. No, does it? No, wait. One, two, three, four. 5 plus 5 is 10 divided by 4. 1, 2, 3, 4 does not work. 2, 3, 4, 5 shouldn't work. Um, 6, 10, 15, right, doesn't work. Maybe it is just those two. Hmm. I wouldn't mind trying to code something to brute force it for ends up to like 20 or something. Oh, 3, 4, 5. Yeah, I'm missing that. Thank you, Silverword. If you like want to try and get this person an answer, I doubt I'm gonna be able to figure this out with pen and paper though. Oh, all right. Let's break out the old VS code then, see if we can get some data. What the hell is this? Oh my god. Why is this in my VS code? Uh, there we go. Oh, this is freaking the files for Daisy. Let's look into mod. Wait. Oh, I know what I'm. One second. This is the wrong version of VS Code to have open. Well, wait. That's how I always ran it though. One second. I need to troubleshoot this. I don't know why it's. Shifting the set until we get 1 in the set. Oh, starting with like the 3, 4, 5 and shifting it backwards each time? I mean, oh no. Um, Coding, Python. Is that the one I want? Oh, I think this is the one. Okay, I figured it out. Let's run This is from the coding competition I did with Zach. Let me run this one just as a test to make sure it's working okay. Okay, cool. It compiles and everything. Let me go one more question. 2025 01 30 .py. Got it. It's pound for comment in this coding language. Oh, 1245 does work also, yeah. I'm probably need to increase the text size or text size. Let me. I guess I'll just do that. Oh, why does that make a black box? What? Tell you what. We'll do this then. Okay. Just put 20 as our upper bound for now. Just to mess around with. I think I'll avoid using NumPy. I think NumPy would be convenient to use, but I don't want to remember how to use everything right now. I don't remember how do you make an array in this stupid language. I've been on C#, so I'm gonna have to remember how to do some basic things. Yeah. Does NumPy have an easy thing to enumerate the power set of a set? I doubt it does subsets at all. Or we can look at it. NumPy power set. NumPy. Really? This does look like it'd be helpful then, right? Power set. Oh, okay. Thank you. I didn't know what a good upper bound would be, so. I just kind of chose 20. We'll start with 10 then. If it runs fast, we can keep on increasing it. Yeah, me neither, Mega. We'll start a little bit lower. Hey, Raven. We're going to question that Megalomorph found on Reddit. And I'm working on coding a solution. Or it's not like a solution, but I'm working on it's getting some values that might help us spot a pattern here. What is this? What do I need to import for this? That's the same exact page. Do a click where the tariffs are imposed in your imports. True. Oh, you know what? Well, the thing I was thinking of NumPy for, Python already has a built-in. It's already super easy to make an array that's like 1, 2, 3 in Python. You don't just do 1:3. Where's the actual documentation for power set? That's what I want. C#. Give me Python. Oh, they're making the code for that. Ugh. If I just try to call power set, will it tell me what thing I should import? That would be great, right? Quick fix. There we go. God bless IDEs, man. What would I do without them? What am I doing wrong here? The parentheses is clearly closed. I don't know what you're on about. If I just try to run this. Wait, does this not give me... Wait. I really wish we had that common blocks for a thing in Python. Does this not give me an array? Wait, I thought that does. Was that like a really cool thing in Python? Python slice operator. I think that's what it's called. Oh, range. Range. Yeah, thank you. I guess it should be that. Average value theorem in calculus? Yeah, mathematician, do you have a question about it? Just say 1 to 5. Why do you keep telling me this? Oh wait, I think you do a comma. Okay. I probably need list range. 1, 2, 3, 4. Okay, cool. Not inclusive. That's fine. We can deal with that. Yeah, I feel like there's some kind of convenient way to define a list like that, but it's fine. Okay, so we want power set list range 1 to I plus 1. Really? I keep doing that. Okay. Let's just do n equals 5 to keep it manageable. What? Stop. That's giving me the the memory addresses. No, stop. I'm not. Oh my god. Freaking hell, dude. Yep. I'm sure not. Okay. That seems to be working okay, right? Empty set, singletons. I think that's giving us what we want here. Multiples of sum of the length. Okay, let me quickly look at mathematicians. Question about average value theorem. Or you're just asking like how it works. I honestly I just want to give you pause on my notes for this because um I guess this average value theorem for derivatives and integrals. I'm not sure if you want one over the other. I think you were asking about fundamental theorem calculus before. And this probably explain it better than I can. What page is it on? The average value theorem for integrals, like the 1 over b minus a integral. Or mean value theorem. So this page that I want, no, it's gonna be the derivative version. Average function value, there we go. This bad boy. Uh, yeah, so I like this page because they generally give people they generally give things in a relatively digestible way. Yeah, so Megor was saying the one sentence version where the every function that's continuous at least has to achieve its average value somewhere in that interval. Like it just has to pass through its average is all it's really saying. But if you want actual proof, then this is probably a good place to start. What I was saying is that the average value of the function, if you draw that like the height of it on the xy plane, the function will pass through that value at some point in that interval. What about it doesn't make sense? You show me on Desmos a visual proof. Uh, I don't have a Desmos like built for that. I don't really have Desmos built for anything in particular. Yeah, this person is over in the YouTube chat, Megalomorph. And I really wish I could show it up there, but there's a Twitch policy saying that I can't. So I'm mostly I'm tempted to just show it anyway and see if I get in trouble, but I haven't really quite taken that step. Um, I can try to find something for you, but I don't really have anything prepared. Like, I don't quite know how to show it in a visual way offhand, to be honest. That looks like the one for derivatives. Yep. This looks like an MP for the right one. Okay, yeah. It's like he's doing some example problems later on here too. Um, but basically all it says is that if you get the like if the function is that like dark line on the top of that shaded region, the average value of the function is somewhere like along here also is all it's really saying. If you want, I can link the actual like YouTube video, but like I feel like trying to prepare like a visual proof on Desmos is something I would need like time to think about and understand it more for myself than I like have offhand. So yeah, I'm sorry that I don't have like a better response for you, but it's just like it's a good question. It just takes a lot of thought to actually like respond to give it a good response. That I can't just do like on the spot, I guess. Yep. Thanks for asking. Okay, so since we're fairly confident this seems to be working okay, um, for S in P set, filter them for things whose sum is a multiple of the length. I like that. Uh, I think sum is a built-in function. If S sum mod length of S is equal to 0. Oh, is that not how you do the length of a... Oh, maybe we want that as a list. I don't know what power set is returning exactly. Really? I can never remember how you get the length of an array in Python. Or a list. Let me Google it. Python list length. Hey, hourly dose of internet. Len. Oh my god. I wonder if this is going to cause an issue with the empty set. Your son loves math. Oh, awesome. In grade 10? Nice. That's awesome. What math class is he doing? How do I want to track these? Has that done Python Kidu list comprehension? No, McGorfer, I'm rusty as hell. I've never written a... I know that some languages have that. I've never written a line like that for myself, though. Shout out to your son? It sure there. Is that what you wanted? I don't know. For coding, especially like for coding like where I'm trying to get someone to answer, I definitely don't mind backseating on that. Phobos is really a person to ask. Let's see, like list comprehension. Let's see what comes up if we Google that. Because I do want to print out the actual arrays that work. And it sounds like that's what you're going for also. Oh, hey, look at that. Perfect. Newest equals x for x in fruits if a in x. So we can avoid this for loop even. So what? I really does have internet. I don't know what you want. Um, answers equals a or a in mathematician. No, you can't. Sorry. S if, what were you writing? Sum of s mod length of s is 0. Or s and s, yeah. Or wait, for s in p set. Oh wait, no, I think we do need this for loop out here because p set is a list. Wait. P set is a list of lists of lists, right? Is this three dimensional or two? Pine code? I never heard of pine code. Because I don't need more mods. Mathematician. I wouldn't need that one. P set is going to be a list of lists. For A and P set. So if I got rid of this for loop and I made that a P set, you're saying if some A. Oh, those S's should not have been S's. I mean, I mean, we'll just try and run this. I feel like this isn't going to work. Isn't it going to be going over this entire thing here, for example? Well, I mean, I'll just freaking print it, but mathematician, you're ignoring me. I'm sorry, you're ignoring me. I mean, I was reading your comment as you're annoying me. That's why you can't be a mod. Do you prefer that answer? What does that do? You keep asking to be a mod. That's how you're annoying me. You're gonna get timed out if you keep asking. Sai ready. You need help with trig? Yeah. What's the question? Oh, it's the empty set. Oh yeah. I was wondering if the empty set will cause issues for modding. Hey Fizzbuzz. Um, how do we deal with that? I don't know if list comprehension will work if the empty sets. That yeah, we'll try that. Oh yeah, maybe I should make that like a pin or something, because I'm not always showing the original one. I do have mods, yes. Explain why life is like a box of chocolates. Only Forrest Gump can. Let's do p set equals p set 1 colon. Ooh, yeah. That could work. Alright, mathematician. I warned you. You're going in timeout. You don't understand the inverses of trig functions. Yeah, I can definitely talk about those. Let me... Well, I want to see if this code here works quickly, and then... It seemed like it was in that little test code. Just give me a minute to see if we can get this code to work, and then I'll talk about it. This seems like it matches with what I was doing with pen and paper, right? Oh, I was missing out on these sets. Oh my god. I should count these as well, right? That'd be a helpful thing. It's not really easy to count the length of each of them individually, though. Wait, yes I can. Print answers. Is this how string concatenation works in Python? I hope it does. Or I hope it is. I might need to put, like, a string around that. Let's try it without, but I think I need to put str. Yeah, I do. Oh, I need to put... Concatenate list. Bindiri. Shout out to Bindiri. There you go. Can I just make that a string? Just put strs on everything? Hey, okay. 1, 2, 5, 8, 15. Okay. So we can up the ends. What does 10 do? Ooh. $135. Maybe we don't want the entire thing for this big of a... Maybe let's go to just the length. I'm sure there's a more convenient way. I should be using a format string to do this. I don't remember how they work in Python, though. So I'm going to do it the old-fashioned way. Seeing what's not an OEIS. I'll rip. There's no hope. 1, 2, 5, 8, 15, 26, 45, 76. There might be some merit in splitting up even versus odd. Because I do think those are going to behave differently. Hey, Amir. Okay, so this is a start. If you want to, I can get some more values here. Does it run for n equals 20? I do want to talk about inverse trig functions for psi ready, though. Oh, hey, that's not bad runtime at all. You can see it pause for a little bit. It's Fibonacci numbers, but everything is wrong after I equals 4. True. And you also have to forget about 3. Oh, you found something in OEIS? Ooh, that's a big find. Conjecture. That's... Oh my gosh. Okay. That is a nice find. I guess someone else already explored this problem. I'm not going to be able to understand this quickly, though. Let me talk about inverse trig functions for SciReady. SciReady, I hope you're still here. Thanks for your patience. And we can come back to this problem, too. So you don't understand the inverses of trig functions, you're saying, SciReady. Actually, Saturday, are you still here? Can you just say that before I go into an explanation? You are? Okay, cool, cool. So let's talk about inverse functions in general. When you have a function, let's just take a parabola. And you want to find the inverse of that parabola? Well, yeah, Fizzbuzz, we tried for a while to do with pen and paper, but it seems hard to get a pattern. Like you can't really force all of these subsets to have a certain structure that we can find without getting into a million cases. And so that's when we go to the old reliable program some code and look for a pattern in the results. But yeah, so if we have a parabola, we want to find the inverse of the parabola. What finding the inverse does is it reflects the function across the line y equals x. So if you take the parabola and reflect it across that line, you get something that looks like this. Now, the issue with this is that you might remember the vertical line test for a function, or at least that's a pretty common thing to get taught, where if you draw a vertical line and hit the function twice or more, it's not a function. I timed you out, the mathematician, for 5 minutes, but you go and make an alt account just to type again? Goodbye. Okay. So yeah, the issue with that is that it fails the vertical line test, and so you can force it to work with the vertical line test if you chop off the upper or lower half. Usually people chop off the lower half and you just get that. So that's kind of the primer on what an inverse function in general is and some issues that can come up in finding the inverse. Now, when we get to trig functions, let's just take sine. Sine looks like that out to infinity and like that out to negative infinity. If you take the inverse of this, what you would have is, I might have it reflected. No, okay, it'll be like this. It'll be like the exact same thing, but along the y-axis now. And so for the exact same reason, this thing is going to fail the vertical line test. So we've got to make a cut to this function somewhere. And the convention for where we make that cut, you could make the cut anywhere you want in theory, as long as it's consistent. But the convention we normally use is to cut it right here and here. And so this little bit in this box, it does pass the vertical line test. I only speak English. And so what we end up with is a function that looks like that little thing. It reminds me of the DNA strand, to be honest, but I don't know why, because it's not really, it only looks kind of like one. And so that corresponds with this piece of the graph here. What language would you learn if you could? Probably Spanish. And so at this maximum, the x and y are pi over 2 comma 1. Over here, it's minus pi over 2 minus 1. And so remember, an inverse function switches the x and y values. So when we come over here, this endpoint over here is just the switched version of those two. So 1 comma pi over 2, minus 1 minus pi over 2. Does Twitch pay me? Yes, but not much. And so that's how I remember the ranges for each of these trig functions, like these inverse trig functions. So if we have inverse sine, or I prefer the notation arc sine, equals y, x has to be between -1 and 1. That's the only values for x we're allowed to plug in. And we'll only ever get out y values from minus pi over 2 to pi over 2. And so that's why we get these weird restrictions with inverse trig functions because of that vertical line test. And there's even more issues where a full period of the sine, like this only covers half a period of sine. And so if you want to get something that's, say, in this region here, you have to do some extra work with a unit circle. Some effects, yeah, I can do that. Let me finish this explanation first, though. So basically, this piece of the graph here, sorry, well, I should say like there, corresponds with Q1 on the unit circle. And that piece there corresponds with Q4. So inverse sine only ever gives you things on the right side of the unit circle, because Q1 is here and Q4 is there. But they'll sometimes give you a triangle that's over here in Q2 and ask you what that angle is. And if they're asking if that's your context, then you can't trust at face value what arcsine gives you from a calculator. You need to modify it. It's only Q1 and Q4 because of that cut that we made. Because we're only taking this piece of the sine graph, these pieces of the sine graph correspond with Q1 and Q4. We could cut it differently to get different quarters, but we'll only ever we'll only ever cover 2 of them at a time, because of how that vertical line test works. How do they correspond? That's a good question. So they correspond because these are x values between 0 and pi over 2 in this piece here. And angles between 0 and pi over 2 are in Q1 on the unit circle here. Remember, sine takes an angle as the input. You know, sine of angle equals ratio. The ratio being opposite over hypotenuse. And same thing down here. So from 0 to minus pi over 2, that's down here in Q4. That makes sense? Awesome. Glad to hear it. So let's say the question is let's say we have a triangle out here. That's, I'm going to give a unit circle value for that point there. Let's call it minus root 3 over 2, comma 1/2. And they want us to find like what the unit circle angle is around here. Let's call it theta. Is this a good example problem? What are we going to get for that? Let me... This might not be the best example problem. Let's just work through it though. There's an easier way to do it too, but if we want to make ourselves use arcsine, this is, because it's a unit circle value, we know the hypotenuse of this triangle is 1. It should be 150, I think. And there is an easier way to do this problem, but if we're going to make ourselves use arcsine, that's what I'm trying to search for. It's probably a better example problem to use here. But if the hypotenuse is 1, no, I don't think it's a good example problem. I can't think of a good one though. The trick, I can tell you like what you do though. For example, I'm drawing a blank for a good example problem. If the point you want is in Q2, arcsine is going to give you something in Q1. And how you translate it is you take whatever angle it gives you here in Q1 and do pi minus that. So you do pi minus that, maybe I'll say arcsine, whatever that number is. And that'll get you this angle over here. I'm kind of, I mean, I wish I could think of a better example problem. I'm kind of failing on that though. But the pattern to remember is that if you need to get to a different quadrant, you want to take pi minus your result, and it does kind of take some thought about what arcsine is going to give you and where you want to get. But normally you want to go in some pattern of like something involving pi minus arcsine. Yeah, I'm sorry. I racked my mind looking for a better example. Maybe Paul will have one. Where's the trig? Oh, here. No. Dang it, Paul. Okay, I'm sorry. If you have a problem that you've been like having a hard time with, do let me know. But other than that, I'm just gonna leave it at saying all this has been about sine. For cosine, we can follow a similar process. That's cosine. Except for cosine, um, we actually cut the function at 0 and pi. So cosine's a little bit different. So inverse cosine looks like that. But that's the same process. This point down here is the same as this point right here. That's 0, 1. So this is 1, 0. And this point up here corresponds with that point down here. This is pi minus 1. So this is minus 1 pi. And the last one, tangent. Tangent is a funkier function because it has all these asymptotes. The moral of the story, we cut out all the other ones and we only reflect this middle one here. So these vertical asymptotes become horizontal asymptotes. Because everything got reflected. And oops. And so ugh. Inverse tangent has the same restriction as arcsine of minus pi over 2 to pi over 2 for that reason. That's why I say cosine is the odd one out because it's restricted from or I'm sorry. I should say restrictions on the y, like the range of it. Inverse sine and inverse tangent are both minus pi over 2 to pi over 2. Cosine is 0 to pi. That's why that's the odd one out. So if this helps you understand these trig functions a little bit, let me know if you have a specific question. But if not, I think I'll move on to Simply Facts question. Are you still here, Simply Facts? Hey, $10. Oh, no, I'm sorry. I don't think I have anything more to say about the question that Megalomorph posted. Is I don't have any more thoughts to like go down that route besides I can paste in somewhere the results of my code, but I don't think I have anything else to say on that. I guess Fizzbuzz is finding out OEAS is the best that we can do. Or the best I can do. Simply Facts hasn't Respond, let me type their name in chat. Gotta get as much money as I can. I like emote before I lose it. I don't blame you. It is a good emote. I assume someone photoshopped that to make him have that expression, and it's really good. Okay, somebody was asking about explaining why the graphs of cosecant, secant, and cotangent look like that. Which I would love to explain, but I want them to be here for ideally. So I'm gonna go back to the analysis maybe. Oh, you have another thought on this one, Mega? Generating function approach. Generating series where the coefficient of x to the n, y to the k is subsets of 1, 2, 3, n of size k. Manipulation to extract just the right coefficients. Hey, Atari X Head Gaming something. If you drink with mouth not touching the bottle, there's no bacteria, etc. I feel like if your bottle has bacteria, you need to clean it more. Welcome in though. Generating series where the coefficient x to the n, y to the k is subsets of 1, 2, 3, n of size k. It'd be interesting to see, but everything I know about generating functions from that 3 blue 1 brown video that I just watched on Tuesday, so I don't know much. Hey, Manon. Concepts containing n. The video was super cool. Oh yeah, you weren't here for that, but Papadoria did come back and ask about that earlier in the stream. So I tried to recount as much as I can remember from the video. Uh, where am I? I'm here. Uh, there's a really cool. I did think it was super cool how apparently the act of multiplying out this generating function mirrors exactly every possibility of generating every subset. If you think about making a subset as a binary choice of whether you include 1 or not, or 2 or not, or 3 or not. And then the connection with complex variables was crazy, and it made sense in the way that he presented it, though. I'm not gonna lie, it did get me a little bit interested in generating functions. Because it just seems kind of wild. Yeah, and I've seen the 3 blue 1 brown explanation for this problem, Phantom Box. I had no hope of solving this blind. The thing is, Papadori apparently didn't learn about generating functions either, so I have no clue how they're expected to do that problem. Um, It is like an Olympiad level problem, though, it seems. So whatever class they're in is apparently for pretty cracked students, I guess. Oh, I got that part slightly wrong. Yeah, yeah, yeah. Yeah, I think you need to get it. I was telling Papadori at the time we only need to worry about the coefficient of x to the fifth. It might have been every multiple of five though. Now that I think about it, or I think it was. I I did relink the video to Papadori though, and I qualified it with saying like I might be misremembering a certain part. Um, no, yeah, you do have to add up every coefficient that's a multiple of five. Oh well. Yeah, I mean, even after you realize that this is like this realizing the generating function is helpful is only the first step. There's still a bunch of work after that. I think the answer ends up being you take 1/5 times the sum of the function of the fifth roots of unity. Added, yeah. But actually, like getting there in a way that makes sense is not simple. Manon is saying expand the following up to 4 times, taking the values of x such that the expansion in each case is valid. Uh, I'm not sure I understand the question, Manon. Let me. Feel like fifth roots, if you need to sum it up, all the powers of x that aren't multiples of 5 cancel out. Yes, that was the idea. and I forgot that at a time when I was trying to relay that to Papadoria. But that was like the entire point of doing that. Um, okay, so Manon, this is where it's hard to interpret a YouTube chat. So let me. There's a couple different ways to interpret this question. Let me ask you which one you mean here. So is this x to the 6 to the power of 7 divided by 3, or is this x minus 6 to the power of 7 divided by 3? I guess like first or second. What time is it? Okay, I'm good. Yeah, megamorph. I feel like it's probably the second one, and the point of the question is to use binomial expansion. But I mean, I'm not quite sure what to interpret, how to interpret that. Set up for what? Go away. I keep getting a weird pop-up. I don't know what program it's related to. PEMDAS says it's the first, but I understand your doubt. Okay, PEMDAS says it's the first, but I've had more than my fair share of people putting problems in chat that don't respect PEMDAS. Oh yeah, that updated steak picture looked a lot better central. Yeah, Mega. I don't see a response from Manon, so they may have dipped out, or maybe there's a weird delay. It looked raw in that first picture. I thought I thought at the time though you were saying that that's just how you liked it. All right, so Manon, let me know which one you mean, but I'm not seeing a response to you, so for now I'm gonna move on. I was gonna say those topside joint. Oh, okay. Well, whatever the beef was, it was underdone for my taste. Medium rare pork just for you. The pork did look amazing. Oh yeah, it would be hard to tell if it was medium rare. It did look cooked through from the bit that I saw though. Do I still have the Desmos link for this analysis problem up? My God. That's what happens every time I code. I end up with a million tabs open. What's my favorite second monitor? Shodan? Wait, what is my favorite second monitor? Or do you want me to show my second monitor? Literally the only thing on my second monitor is OBS and Discord. It's nothing exciting. Oh, I get the question. What do you watch while gaming or working? Usually a Twitch stream these days. Sometimes music, but I've been watching a lot of Twitch. Oh, this function is annoying. Watching Twitch of late too. Yeah. The issue that I've been having now is that I've been starting to play Baldur's Gate 3 off stream. And I guess that game is taking so many of my computer's resources that like it can barely handle the Twitch stream on the second monitor. So even after turning the graphics settings way down, it's still struggling. I think for this function, it's not converging at all at around x equals 1. Like, you don't want x equals 1 involved anywhere. How's your math test? Oh, good luck, Manon. So wait, Manon, I asked you a question. Maybe you stepped away before you could hear, though. But I don't know how to interpret the question that you asked. Like, is it the first one or the second one? Hey, Hanyolo. Slept for 9 hours, I feel so lazy, you can't think about making a coffee. Oh my god. That's like a self-fulfilling prophecy there. You're too tired to make coffee, so you feel more tired because you haven't had coffee. What does math question say cometh? It's a problem that Zach made up for the analysis class, so he likes to put in like little jokes and things. Okay, so I'm not seeing a response, Manon. Let me know which one you mean. I have to answer your question, but I'm not sure which one. You cometh on the math class. Cometh to the math class. Okay. Let's say you might want to ask for consent before it cometh on the math class. That's what real anal is all about. Okay. So you do mean the second one then. Uh So I'm still not quite sure how to interpret the original question, but I think I have a guess at it. Um, ugh. Wait, what? Does this still work for rational powers? How do you deal with that again? Interesting. So I guess Manon, does this look familiar to you? Because I think you would have to use this formula. I'm not quite sure what they mean with the up to 4 times. But if you wanted to expand this expression here, I think this is the formula that you want. Yes, it does look familiar. Okay. Um, so I think if we were to apply the formula here, we'd take x minus 6 equal to the sum, k equals 0. Maybe they mean just get 4 terms. Okay, and then if we start to apply the formula here, our first term is just x to the r, so x to the 7 over 3, plus now r, x to the r minus 1 times y, so r is 7/3. 7/3 minus 1 is 4/3 times y, plus, now we're on this term here, 7/3 times 4/3 over 2 factorial, which we can simplify later. R minus 2 is same thing as 4/3 minus 1, which is 1/3. Y squared. Oh, sorry. Y is a number. Y is -6, right? Squared. Plus 7/3 times 4/3 times 1/3 over 3 factorial. X to the now 1/3 minus 3 is -2/3. Y, which is 6, -6 cubed. And so that's our 4 terms that I assume they want. So after this, we'll do plus ... because it does go on forever, but we're not going to go... We're going to get every infinite term. Or every term out to infinity. So there's nothing about simplifying the first term. The second term, we can make that into what? -14. X to the 4/3. The next term, we can do plus... Ugh. Those 3's can cancel with the 6. 56? if we work out that math and that math, the 3's from the 6 squared both cancel. One of the 2's cancels. 7 times 4 is 28. 28 times 2 is 56. So I think that's right. Now the other term will get a minus. The 3 factorial cancels with one of the 6's. For the same trick, I think now we have 56 over 3. No? Yes. No? Yes. 56 over 3. Does 56 go? No, that's not a multiple. So I think that's the answer there, Manon. I haven't done this in a minute, but if you know the formula, it's a matter of just applying it, I guess. Actually, take that as x such that the expansion in each case is valid. It looks like we do need to hold absolute value of x is greater than absolute value of 6. We should be worrying about that, right? Oh, wait. Oh, no, I missed out on this part? Oh, should I have stopped once I got a negative power? No goes for k greater than r. Oh, no, I might have gone too far. K greater than r. 7/3 is 2 into third. Oh, dang. I think I went too far. Let me, you know what? I'm getting less confident now. Let me plug this into Wolfram Alpha. The last 2 terms I did might not be valid. It's been a minute since I've done this, though. No, maybe it does keep on going. Hmm. Does just the regular binomial theorem work for fractional? Things, how do you deal with the combination? Yeah, I'm sorry. I'm getting a lot less confident in this now. So I feel like we do need this version. Maybe we did k greater than r or 0. Oh wait, no, that's an integer. We don't have an integer. The series typically has infinitely many non-zero terms. Oh no, I think we're good then. I think what I wrote is fine. Yeah, it shouldn't be able to be represented with a finite number of terms, right? That doesn't make sense. Okay. No, I think what I wrote is okay then. I believe that this is the answer to the question then. I just need to work through the requirements of that formula, but I think this is right. Sorry that I'm not more like confident about that, but I actually, ooh, you know what? There was the other the formula does require that the absolute value of x be greater than the absolute value of y. So I do think in response to like that piece of the question, we do need to hold that the absolute value of x is greater than 6. So with that stipulation, I think this formula is okay. Yeah, I think that's my answer there, Manon. Um, I'll give you a question about it and I'll try, but I might wrap up the stream here because I want to go and make some food before the analysis class starts up. And that's going to be sooner rather than later, like less than an hour. So if you do have a question, just let me know quick, Manon. Otherwise, I'm going to wrap things up. Hmm. Yeah, that question will be for another day. Migration processes. I never heard of those, but I need to go make some food though. Like I'm running out of time before Zach's class is going to start. It's in less than an hour. Another day I'll like at least like look at something. I'm usually not very good at understanding things quickly though, so I can't promise you much. Raid Zach. The issue is that I want to eat, and I don't just want to have my stream be AFK until Zach goes live. Uh, so yeah, I haven't seen Manon type anything, so I'm gonna cut the YouTube stream off here, and then we'll look for someone to raid on Twitch. So anyone's here on YouTube, thanks for being here. I'll be back on YouTube on Saturday. What am I? Oh my god.